right, today we'll be finishing section 1.2. This is the last learning target that we did not get to, describing these different sampling techniques. All right, so on page 16 in your textbook is where this begins. We're going to go over this a few different ways. We're going to go through by having you reading it first. Then I'll take you through an example of each on this sampling techniques page. And then we'll follow it up with a YouTube video with some good visual aids. Okay, so pause the video, start by reading those two pages, 16 and 17. Okay, here we go. Stratified sampling. Let's write this down in this first box. This refers to groups or classes inside a population that share a common characteristic. And that's kind of the reason they call it stratified is because the word strata means, it's another word for like a group. Okay, so it's good to provide an example for these. I want you to try to put this in here as well. Break up a school into grade level, then draw SRSs of 50 from each grade level. Because maybe you're taking a survey about opinion on cafeteria food. You might know that the opinion on this for freshmen varies differently than seniors. So you might want to break up that data to see the differences, okay? So even though it's not a true SRS, doesn't mean it's a bad sampling technique. It's a very good sampling technique if you want to see differences between these stratas. Right? I'm going too fast at home. Just pause this because I'm pausing this in class as well. All right, so a lot of students get these two confused, stratified and cluster sampling. So it's good to have these side by side. All right, so here's the definition for cluster sampling. You begin by dividing the demographic area into sections. Like counties and zip codes are a good example of this, and we'll use that as an example in a little bit. Then we randomly select these sections, or these, that's what I call clusters, I guess. Clusters are like sections. Every member of that cluster is included in the sample. At least that's the attempt. You might not reach everybody. That has a phrase in Stats 2 called non-response, but they're at least included in the sample. Okay, so. All right, so here's the example for this one. In conducting a survey in a large city, we could first randomly select 5 schools in that city, then include all the children from each school. So maybe there's like 20 schools or 30 schools in the city. If we just randomly select 5, we hope that that's a good representation of all the schools, and that will be our sample. We get all the kids from that school. Cluster samples should kind of look like a vial of blood being drawn from your body, right? If I take a vial of blood, that blood looks like all the blood in your body. When you take a cluster sample, you're hoping the sample is a good representation of everything. So a good school example was back in the day when we had 3 lunch periods. We could randomly select 1 lunch period, and that sample should be a good representation of the entire school body, right? The stratified, though, the school example I gave you, is if you break them up into grade levels, we know we probably see they are different from group to group. Cluster should look the same as the population. Okay. All right. Moving on. Any questions on that? Okay. Systematic sampling. Here's what this reads. Select a random starting points and select every kth element or nth elements for our sample. Okay. So what that means, like a variable, right? You decide I'm going to choose every 10th off the assembly line. Or students are walking in the building. I'm going to choose every 20th student, and I'm going to survey that kid. Okay, another good way to randomly select people. It's used quite a bit at factories because sometimes you don't want to take the first hour production or the last hour production. Okay, for obvious reasons, the machines might operate differently, or you've got different people on the assembly line. Okay, so here's the example. To analyze the brakes on newly made cars, a random car is chosen to begin with, and then every 10th car after that is included in the sample. All right, convenience sampling. This one is actually an example of not a very good method, but you need to be aware of it because if somebody uses a convenience sample, you need to know that the data probably has bias in it. So here's the definition. Create a sample by using data from population members that are readily available. You do it because it's convenient. You don't have to use a lot of resources. But chances are this results in bias quite a bit. If your teacher asks you to conduct a survey and go get some data, but all you do is just ask your friends. Well, your friends sometimes aren't like everybody else. Okay, so that's my example. Only asking your friends to fill out a survey. Okay. All right, it's good to add this part too. We'll get to voluntary response in just a moment, but you should know that these two will most likely contain bias. Bias just means a misrepresentation of the truth, and you don't want your samples to be a misrepresentation of the truth. There's too much of that going on these days. Right? We want the truth. Okay, so with that being said, let's take a look at what voluntary response sample is. This occurs when sample members are self-selected. You choose to participate, right? So that's what it means by self-selected. If you want to say that, members choose to participate. Often these folks have a strong opinion on the topic. So here's some example of these. Online polls or call-in votes. You can put below call-in votes American Idol. That's a huge voluntary response survey, right? Not everybody participates. The people that decide to call in and cast their vote. So sometimes you get, especially for online polls, do you agree with this or that? People that have very strong opinions, usually towards the negative side of things, tend to participate. So that's usually the way it will swing. Are you in favor of this new tax hike? Some people that are like, I'm okay with it. They're not going to call in. People that are ticked off about the tax hike will call in. Does that make sense? They want to pick up the phone. So they're usually skewed one way or the other. Okay? They're biased one way or the other. All right, and the last one, multi-stage sampling. Let's keep this real simple because we're not going to get into details of this because it can get pretty complex. Advanced people that are going out there and doing this for a career need to know how to do this well. For you guys, I just want you to know this. Uses a variety of these sampling methods. You can just stop there, okay? Uses a variety of sampling methods. So if you see a description where they're just saying, well, we're going to choose a few counties as a cluster sample, then from there, we're going to break it up by ethnicity, or they're going to break it up by political party. Now they've stratified it. So they're using two techniques, okay? It's advanced. Don't worry about it. But all you got to worry about is if they talk about using more than one of these techniques up here, then we just call it multi-stage, okay? Okay, so to follow up with this, I'm going to show a video. I'm also going to put this link online for you guys to view. You should check it out. It really does a nice job of showing some visual aids on the difference of these two, especially the stratified and cluster samples. Okay. Okay, so here we go. Here's the last page. At home, go ahead and read page 18, then fill in the following definitions. Here's what a sampling frame means. It's the list of individuals from which a sample is actually selected. All right, so we are doing a cluster sample, and we end up having Genesee County as part of our sample, then the list of individuals, everybody in Genesee County. Okay, now sometimes you don't reach everybody in Genesee County for whatever you're trying to do, and that's called undercoverage. All right, omitting population members from the sample frame. I was actually getting ahead of myself talking about non-response a little bit. Undercoverage is when you create some type of way to reach these people, but naturally you're going to have some populations removed. Like, for example, a landline survey. Okay? Landline survey undercovers homes that are cell phone only. Okay? Another group of people that's going to undercover is the inmates and the homeless. They aren't going to be part of that group now if you just stuck with a landline survey. So there's an example of undercoverage. Okay, sampling error. I just mentioned this in the video too at the very end. When we sample every single time, we don't always hit the truth about the population. Ask two students what their GPA is, add it up, divide by 2, it might not be the same as the population of the school. Okay? That's called sampling error. The difference between measurements from a sample and corresponding measurements from the population. It's just a natural cause by the fact that the sample does not perfectly represent the population. Okay, if you can't read any of my words here, it's too sloppy. Page 18 is where this is at. Okay, a little trick on words here though. Non-sampling error, that's the result of poor sample design. Sloppy data collection, so maybe like a convenient sample or voluntary response. That's a non-sampling error. All right, so think about sampling error, something that should naturally occur. We expect that. But if the error is due to something not from sampling and something else, then that's what we call it, non-sampling error. Okay, so just summarize that last thing I put there was sampling errors do not represent mistakes. It naturally happens. Okay? They are simply the consequences of using samples versus the entire population. Okay, we'll just wrap it up by looking at this viewpoint, and we'll be done with section 1.2. So just read that, and then we'll be done.